Welcome to the lesson on the relationship between zeros and coefficients of a polynomial. At the end of this lesson, you will be able to establish the relationship between the zeros and the coefficients of linear polynomials, quadratic polynomials, and cubic polynomials. Let's consider a linear polynomial 2x plus 5. Here x is the variable with 2 as its coefficient and 5 is the constant term. Now, let's find the zero of this polynomial. The zero of a polynomial is defined as any real number k, for which the value of the polynomial becomes 0. Let's assume that for x equal to alpha, the value of p of x becomes 0. Thus, p of alpha is equal to 0. This implies that 2 alpha plus 5 is equal to 0. On simplification, we get the value of alpha as minus 5 divided by 2. Here you observe that the numerator 5 is the constant term of the polynomial, and the denominator 2 is the coefficient of the variable x. Based on this observation, we can conclude that the zero of a linear polynomial is equal to the minus of the constant term divided by the coefficient of x. Now, let's consider the general form of the linear polynomial p of x is equal to ax plus b, where a is not equal to 0. Recall that a linear polynomial can have a maximum of one zero. Let's assume that alpha is the zero of the linear polynomial ax plus b. Hence, we can say that p of alpha is equal to 0. This implies that a multiplied by alpha plus b is equal to 0. On simplifying this expression, we get alpha is equal to minus b divided by a. Here b is the constant term and a is the coefficient of the variable x of the linear polynomial. This equation defines the relationship between the zero and the coefficient of the linear polynomial. Next, we'll discuss the relationship between the zeros of quadratic and cubic polynomials with its coefficients. Let's consider the general form of the quadratic polynomial. Recall that a quadratic polynomial can have a maximum of two zeros. Let's assume that the zeros of the polynomial p of x are alpha and beta. Here we will apply the factor theorem to determine the factors of p of x. Recall that the factor theorem states that if a is a zero of a polynomial p of x, then x minus a is a factor of p of x. In case of a quadratic polynomial, if alpha and beta are zeros of the polynomial p of x, then the factors of p of x are x minus alpha and x minus beta. Thus, the quadratic polynomial is equal to k multiplied by x minus alpha multiplied by x minus beta, where k is a constant not equal to 0. Let's multiply the factors on the right-hand side of the equation. The equation obtained is as shown. Now, let's compare the coefficients on both the sides of the equation. A is equal to k. This is by comparing the coefficient of x square. Let this be equation 1. B is equal to minus k multiplied by alpha plus beta. This is by comparing the coefficient of x. Let this be equation 2. and c is equal to k multiplied by alpha multiplied by beta. Let this be equation 3. Now, let us use the equation 1 and equation 2 to get this relation. This equation indicates that the sum of the zeros is equal to minus b divided by a. Here b is the coefficient of x and a is the coefficient of x square. Therefore, this equation establishes the relationship between the sum of zeros and coefficients of the quadratic polynomial. On using equation 1 and equation 3, we get the product of zeros, which is equal to c divided by a. Here c is the constant term and a is the coefficient of x square. Therefore, this equation defines the relationship between the product of zeros and the coefficients of a quadratic polynomial.